What if you could automate an entire network lab from cursor and watch everything happen from beginning to end in front of you? Watch this. I'm going to give my AI agent one goal. Build me 2 routers and 2 switches, R1 to S1, R2 to S2, routers linked together, switches not linked, and put 2 VPCs on each switches with IPs already configured. Now, watch what happens. The AI takes the natural language request, follows the NetPulse scale, and runs the Python automation tools that communicate with GNS3's REST API. Step by step, it creates the project, places the devices, wires the links, starts the nodes, and configures the IP addressing automatically. A few seconds later, the entire lab is ready inside GNS3, all from a single prompt. This isn't just a script running in the background. It is an AI agent understanding a network goal, translating it into actions, and executing those actions through the automation layer connected to GNS3. In this tutorial, I'll show you how exactly the system works, how Cursor, the NetPulse agent workflow, and GNS3 fit together, and how you can set it up yourself so you can build and automate network labs like this using AI platforms like Cursor, Anti-Gravity, Codex, and Cloud Code. So the first thing that you need to do is download an AI code editor. Download Cloud Code, Cursor, or Anti-Gravity. Once you download one of these AI code editors, I personally prefer Cursor. Go ahead and open my GitHub repo. The link is in the description for NetPulse Lab Agent. Copy the URL and then open CMD and navigate to the folder where you want to clone the project. For me, I want to go to my Open Drive folder. Once you're there, run git clone and paste the GitHub link so that you clone the exact repository from my GitHub repo. Once you download it successfully, go ahead and open the project with Cursor or any AI code editor that you prefer. The first thing that you have to do is to enter your GNS3 password. If you don't know where it is located in this folder. Go ahead and open the file gns3server.conf and you will find the username and password right there. Go ahead and copy them into the project. Once you set up the password, your computer can communicate with GNS3 and now you have everything set up. So after setting up everything, you go ahead and just install GNS3. This is a very important step because if you don't install GNS3, it would not work. If you watch my video about the Topology Builder, you will understand how it works, how I can generate these types of topologies, and how we connect Python with GNS3. You'll understand it immediately. I highly recommend watching that video because it is a very good way to learn the fundamentals. Once you start at GNS3, you're free to just write anything. Now, let me write a prompt. It will take some time for the agent to modify the code and run the Python code. You can tell the agent where you want to save the project, but if you don't, by default, it is in the GNS3's project folder. Now you can see that the AI is literally doing everything by itself. I'm not even touching anything. It is configuring IP addresses, the routing protocols, and then verifying everything by itself. Now it is the routing verification stage. It writes show running configuration on the router in order to verify everything and make sure it is working properly, because the agent needs to confirm current router state. After the agent is done configuring everything, we can ping each VPCs to any other destination. The reason we're doing is to verify that everything we configure is actually working correctly. When we ping from one VPC to another, we're sending packages from the source to the destination and checking whether they can successfully reach each other. If the ping is successful, it means the VPCs have the correct IP addresses, the routing protocol is working properly, and the network device are forwarding the package to the correct destination. So this confirms that our entire topology and configuration are working correctly. And that's how easy it is. It will literally take you 2 or 3 minutes to configure and verify everything in GNS3. So before we wrap up, I wanted to show you what actually sits inside the project. Because the magic isn't just AI talking to GNS3. If you give a normal LLM a prompt like build me an OSPF lab, it will guess. It might invent APIs, call tools in the wrong order, skip verifications, or rebuild the entire topology just to fix an IP. That's unreliable. That is why the project uses iSkill. iSkill is a written playbook that the agent loads in Cursor or any AI code editor. It tells the model when to act, which tools to run, in what order, and when to stop. Skills turn a vague goal into a repeatable lab workflow. So here's the project stack. At the top, you talking in chat. The chat is the front end. There is no separate React app and no API cloud agent required. Next, the editor skill, NetPulse agents in skill.md file. Cursor discovers these files automatically. This is the control surface. Under that, deeper lab playbooks in backend / skills. Things like guide, topology, canvas, router config, VPCs, verify, plus protocols like OSPF or VLAN when you needed them. Then the Python tools, which actually creates start nodes, push configs, and verify. At the bottom, GNS3 talking over its REST API. GNS3 is just a canvas. The agent does the work and always on rules live in agents.mg. So every editor knows the same ground rules. So if we zoom into the skills itself, what does it actually enforce? First, the trigger. When you ask to build, configure, or verify a network, the agent should run tools immediately, not dump commands for you to copy paste. Select the workflow order, select the project, create topology if needed, apply canvas layout, start devices, wait until the CLI is ready, configure routers in parallel when possible, configure VPCs, IPs, then verify. Wiring defaults. For typical 2 routers, lab R1 pairs to S1, R2 pairs to S2, routers connect on a VLAN link and switches don't connect to each other unless you ask. That stops the agent from inventing a broken fabric. Hard stop rules. If verification passes, stop and summarize. If config fails twice, report and stop. If the lab is ready, complete, do not rebuild it. And finally, the stack rules. AI editor plus GNS3 only. No fake front end, no calling OpenAI APIs for this path. So if we put together everything, a full empty project build looks like this. Check capacity, create topology, lay out the canvas, start devices, wait for the CLI, configure routers, configure hosts, verify the network, then stop. Protocols skills load on demand. If you say OSPF, it reads the OSPF playbook. Same idea for net, VLAN, and the rest. So why do we need the skill? Because tools alone aren't enough. Tools can do anything. The skill teaches the agent how to use those tools correctly for the networking labs, safely, in order, with the right topology rules. So a single sentence in Cursor become a real working GNS3 lab. That's it for the video. I'm your boy Yusuf. Like, subscribe, and see you in the next one.